Hello viewers, in this video we will see the solution to week 2 assignment 2 for the course computer architectures. The solutions are our suggestions. So my suggestions for the first question. So what is the smallest positive d-normal number in the IEEE 754 standard? So the possible, my suggestion is answer option C, 2 power minus 149. Option C, 2 power minus 149. Second question. Consider the following assembly code in the simple RISC ISA. So the solution for this is, so R0 is FB1240, and for the you will see this one. So move H is nothing but FB1240, and move, and the second instruction add U is nothing but unsigned number. The solution that becomes the higher word becomes 4 zeros, and we add these two number. This second number is the immediate number. So if you add these two hexadecimal number, it becomes FB12 CDE. FB12 CDE is the answer for the second problem, second question. So the answer is option B. Option B. Option B. So 0x FB12 CDEF. Third one. Consider the following simple RISC assembly code. So we'll see. So first one is move R1, move R3, and then store the content of R1 to a memory address, then add the content of R1, R3, and it will be stored in R4, and load the content of memory to the R2. We'll see the solution. So here third one. So in the first instruction, after the execution of first instruction, the R1 register will contain 10. After the execution of the second instruction, R3 will contain 5. Then from the the R1 register content is moved to the memory address, which is pointed to by the stack pointer. So R14 register is used as the stack pointer, SP, as a SP. Now the fourth instruction is nothing but content of R1 and R3 is added, and the result will be stored in the R4. So the content of R1 plus R3 is 10 plus 5 is equal to 15. So therefore R4 equal to now 15, and the last instruction is nothing but the content from the content of last, so fifth instruction. What is the fifth instruction here? The last instruction. So load. So from the memory address it is to the R2. So it is from the memory address. From the memory address to the R2 will be 10. So in the memory address it is 10, and that will be copied to R2. So the answer is option A, R. So this is R2. This is R2 equal to 10, R4 equal to 15. R2 equal to 10, R4 equal to 15. Option A. Fourth one. Consider the following simple RISC instruction. So we'll see this one. First is move instruction 20 and LSL logical shift left. We'll see this one. Fourth one. The fourth one. So fourth one, R1 is equal to 20. R1 equal to 20. So this is the binary equivalent of 20. And this is the first shift. So that becomes 20 becomes 40. In the second shift, towards the left side. So now if you convert this binary number into decimal number, this becomes 2 power 6 into 1 plus 2 power 4 into 1 becomes 80. Or you can see here the LSL instruction logical shift left is equivalent to multiplication by 2 power 1, n, where n is the number of shift which is given in the problem. N equal to 2 here, n is equal to 2 here. Therefore simply 20 is the given number, 20 is multiplied by 2 power n, and that is equal to 2 power 20 into 4, that is equal to 80. So therefore R2 will contain 80. So the answer is option A, 80. Option A, 80. Fifth one, the simplest RISC ISA has 16 registers. See the solution. It has option B 16 registers. Those registers are identified as, are named as R0, R1, R2, R3, R4, R5, R6, R7, R8, R9, R10, R11, R12, R13, R14 and R15. Option B 16 registers. Sixth one, which of the following is not a shift instruction in the simplest ISA, simple RISC ISA? The sixth one, so option C, ASL. ASL. So this is left shift, logical shift left. This is logical shift right and logical shift right. But this ASL is not an instruction. So answer is option C. 6 is option C. 6 is option C. Okay. Next we will see 7th. The BGT instruction bases its outcome on the value of dash flags. So BGT is nothing but branch if greater than instruction. So the answer is option B. So that is GT flag. It uses GT flag. It is based on GT flag. Greater than. G stands for greater, T stands for than. So the answer is option B. Answer is option B, GT flag. Next one, a fixed point number has a fixed number of digits. So the solution for this, our suggestion is, the answer is option A. Answer is option A. After the decimal point, it has fixed number of digits after the decimal point. After the decimal points. So ninth one, UTF-32 has 4 bytes for every character. So option B, 4 bytes. Option B, 4 bytes for every character. Option B, 4 bytes for every character. Last one, how many bits are used for the exponent in the IEEE 754 standard for double precision numbers? We will see that one. So double precision numbers, the field S has 1 bit size and exponent E has 11 bits and Ventisa M has 52 bits. So the answer is option A, 11 bits. Option A, 11 bits. Thank you.